Good afternoon. I'm here to do lesson number 5 with you, in which I'll work some problems actually from your homework. I'll work them slowly, sharing with you my thinking process as I do these kind of dimensional analyses problems. So, video lesson number 5, I will share my screen. In video lesson number 5, we're going to continue working with more advanced dimensional analysis. This means not the dimensional analysis in one dimension, but rather we'll be working with squared and cubic units. So what you'll need in front of you for this video lesson to be useful is particularly your homework packet. I won't actually use your class packet today. Maybe a calculator. If you're going to pause the video and do these problems, that would be wonderful. Remember, some people have not yet gotten that homework sheet, and the homework sheet has to be printed individually. It is found in Chapter 2. I highly recommend you print off that homework sheet and staple it to the cover of your homework packet. They go together. The homework sheet tells you what to do in that white homework packet. Remember, tonight you have a homework check on video lessons 2, 3, 4, and 5 to be done by 11:59 tonight. And of course, don't wait until 10 o'clock to start. You should do both of these comfortably in the late afternoon or the early evening. Remember, you have 2 tries to obtain the highest score for me to record. So our goal is to practice 2 and 3 dimensions of dimensional analysis. So I'm actually going to do 2 homework assignments with you: dimensional analysis for intermediates and dimensional analysis for experts. So you have already completed many pages in your class packet. You should have practiced and actually completed pages 1 through 16 in your class packet just to prepare yourself for accomplishing these skills. Tomorrow's video lesson will return to the class packet, where I'll do some final practicing with you before Thursday's test. I'll tell you this several times, but for Thursday's test, you will be taking that test electronically, but during the designated class time. Everyone will have their Zoom on. You'll be working on an electronic test. It'll be as if you're all with me in class. So that's Thursday. I do appreciate that we're really weaving together the threads of completing and testing Chapter 2 this week. But while we're finishing up Chapter 2, you're also learning about the requirements for the IB lab reports by doing the System Lab. The goal of the System Lab is just to introduce one of the beginning requirements of designing a lab. I know it might not be your best data collection because we don't have that much time in a 40-minute period, but it will be a chance for you to document the design of an experiment. I want to remind you that there are slides on the system in the yellow folder, the yellow lab folder. So this is showing us that we're weaving together these different threads of both the chapter content and the lab expectations. We will always be doing a lab with every chapter, and usually they fit together even better than this lab. All right. So here in your homework packet, you have dimensional analysis for intermediates. This was actually due yesterday. This is found on page 7 in your homework packet, page 7. So what I expect you to be able to do is do unit conversion. I'm going to switch my slide to show you my document camera, and I'll highlight some of the more difficult problems here. If you're not having any trouble with these at all, you can fast forward until you see me on a problem that you would be more interested in. So first, I point out on B, to convert 7.96 grams per cubic centimeters to milligrams per square millimeter. I hope I said square centimeter. So first you write down what you're given, 7.96 grams over centimeter squared. Now ultimately you want to convert that to milligrams per millimeter squared. That might sound like an unusual unit. It's not density because it's only in a squared unit. So here you have grams to convert to milligrams. The way I think about this is I need to take grams and convert them to milligrams. The grams will cross out if I put the grams on the bottom. But now I have to think about what is the relationship between grams and milligrams. There are several things you could write down here that would be correct. I know that 1 gram has 1,000 milligrams in it. It would also be correct for you to write down 1 milligram is 0.001 gram. Several correct ways to do this. Now I want to convert centimeters squared to millimeters squared. That would cross out the centimeters squared and end up with millimeters squared. I have to think of these numbers. What are the numbers that go with 1 centimeter squared has how many millimeters squared? Well, if this is a centimeter, I know that there are 10 millimeters in 1 centimeter. And so if you have a square centimeter, that means you have 100 millimeters squared in 1 centimeter squared. That gets you to the correct units, and you can look up the answer on Schoology. I want to purposefully show you C also because there's one step that might be inadvertently skipped, and it's a necessary step. So for C, 1.54 kilograms per liter. And we want to convert that to grams per centimeter cubed. So first, I know that I can get from kilograms to grams fairly easily. I put kilograms on the bottom and grams on the top, but what numbers go with them? The numbers that go with them is 1 kilogram is 1,000 grams. That gets rid of kilograms. But now look at liters. The first thing I would say is that I can go from liters to milliliters. What are the numbers? 1 liter has 1,000 milliliters. That gets rid of liters. Now here's the necessary step. I need to acknowledge that 1 milliliter is 1 centimeter cubed. That is a necessary step. It lets me go from milliliters to centimeters cubed. So you can do that math and look up the answer on Schoology with those units having been accomplished. How many square centimeters are in 1 square kilometer? Here I start with just one number, 1 kilometer squared. I'll go ahead and put it over 1 just so that I see that there is a top and a bottom. Now, if I want to end up with centimeters squared, here is an example. I'd like to demonstrate in this problem. Here's an example where I don't know exactly how many centimeters squared are in a kilometer squared. So I'm going to first go to meters. Meters is the base unit for length. And so I know the relationship between kilometers and meters, and so I can figure out the relationship between kilometers squared and meters squared. I'm going to the base unit because those numbers I'm more comfortable with. So if this is a meter, if that's a kilometer, I know there are 1,000 meters in every kilometer. So if it's squared, then I know that it is 1 times 10 to the 6th meters squared in 1 kilometer squared. So I could figure that out because I knew there were 1,000 meters in 1 kilometer. Now let's go from meters squared to centimeters squared. Here again, I'm going from the base unit. The base is what we're most comfortable with, and that's meter. So if I'm talking about a meter, I know there's 100 centimeters in it. So that means there's 1 times 10 to the 4th centimeters squared in 1 meter squared. So if you do this math, you can see that there's all ones on the bottom. There's a exponent to the 10. So this answer is 1 times 10 to the 10th centimeters squared. I will go to the back side of this page now and do a more complicated problem with you. On the back, I'd like to do number 5. Number 5, showing you how I'm thinking. First, you have to look up the density. And the number that you would look up for the density has lots of numbers in it. I looked up 11.3437716 grams per centimeter cubed. And that is per 1 centimeter cubed, but you don't have to write the 1. Now, I would like that expressed in kilograms per meter cubed. I'm going to a huge volume from a relatively small volume, the volume the tip of my finger. So let us first convert kilograms, grams to kilograms. I can get rid of my grams to get kilograms, but what is the relationship? 1 kilogram is 1,000 grams. Now comes our 3 dimensions. If I want to get rid of centimeters cubed, I put it on the top. Meters cubed, I put it on the bottom. I can cross out my centimeters cubed, but what numbers go in there? For a cubic meter, if this is 1 meter, there's 100 centimeters in that dimension. So you have 100 times 100 times 100 centimeters cubed in a meter cubed. That's 1 times 10 to the 6th centimeters cubed in 1 meter cubed. So if you write out all those answers, you would have a very a large number of significant figures in this answer, and you can look that up in Schoology. I do want to point out one thing here in problem 6. How many minutes will the watch lose in 1 day? That means you're really converting to minutes per day. And you're starting with seconds per minute. So those are the conversions that you would be making, seconds per minute to minutes per day. I just wanted to clarify that, and you can see if you can set that up in dimensional analysis. So that explains some of the problem-solving process that I think through as I do dimensional analysis for intermediates. I'm going to now go to dimensional analysis for experts, and it has a few trickier ones in it. Okay, we'll go on to dimensional analysis for experts. This is also in your homework packet. It's in your homework packet on page 9. Hopefully, as you do these several sheets of dimensional analyses, you're becoming more and more comfortable. It's making more and more sense how to set up and think through these problems. So I'm going to share my screen and only do a few of the problems on Dimensional analysis for experts. There's something I'd like to show you in a couple of different problems. So here we are, dimensional analysis for experts. The first one I want to do is number 1, because I want to assure you of the resource that you will have when you take this test. Here it says to use the density of carbon to convert the density into ounces per millimeter cubed. So I want to end with ounces per millimeter cubed. And I'm going to be starting with this density that I looked up. I looked up 2.25 grams per centimeter cubed is the density of graphite in your appendix at the end of your book. So I have to convert grams to ounces. There is no way I know the relationship between grams and ounces. So remember, you'll be able to use the back side of your class packet. You may have this out while you do the test. Of course, I don't want you looking throughout the whole packet to look up how to do problems. You may have this back page out. So when I look up the conversion, I see that 1 gram is 0.0353 ounces. This is why I'm doing this one problem. I want you to see that I would not have known that. So that tosses out grams, and I now have ounces. Now to convert cubic centimeters to cubic millimeters, how many cubic millimeters are in a cubic centimeter? Well, if this is 1 centimeter, I know it has 10 millimeters. So a square and a cube has 10 by 10 by 10 millimeters. That would be 1 times 10 to the third millimeters in 1 cubic centimeter. If you take and multiply all that out, remember we multiply it once going across. If the number's on the top, you multiply. If the number's on the bottom, you divide. So I would punch 2.25 into my calculator times 0.0353 divided by 1 times 10 to the third. And there you would write your answer. You can look that up on Schoology. Know that sig figs, unit, and the number itself counts. Now I'd like to do number 3. Number 3 is interesting, and here is my lesson to point out here. For number 3, it says you have 5 mils of mercury. And you're going to put it into a beaker that already has a mass of 87.3. So how much does the beaker weigh after you add that much more mercury? Well, 5 mils of mercury is not a mass. I need to know what mass is in 5 mils. That's where I use the conversion. Density is actually an equality. If density is grams per centimeter cubed, it's really like saying for mercury, 13.5462 grams of mercury equals 1 centimeter cubed of mercury. Hg is the symbol for mercury, Hg. So you see, density is an equality. So what I have in this problem is a simple number and a more complex number, which is grams per cubic centimeter. Always start with the simple number. So if you start with 5.00 mils of mercury, start with that number. You'll be off to the right foot. So now, you don't really want mils, you want to end with a mass in grams. You want to end with mass of mercury. So first we would have to convert mils to cubic centimeters because that's what the density is in. So I know 1 mil is 1 cubic centimeter. You must write that. It is a conversion that has to be indicated. And here is the special one. This is special. This is where I can use my density. I know that 1 cubic centimeter of mercury has a mass of 13.5462 grams. That's the special conversion unit made from the equality that is the density. So there, if I solve for that, I will end up with 67.7 grams of mercury. So I highlight that, but I'm not done. They want to know the mass of the beaker that has that much mercury in it. So if you take 87.3 grams for the beaker and 67.7 grams for the mercury, that adds up to 0.551 grams total. Now remember, you have to go to this place value. So you actually end up with 4 sig figs in your answer. This is your answer because when you add those two numbers, you gain a sig fig. This is the necessary answer to get towards the final answer. All right, there is just one more I'd like to do to emphasize when you have several numbers in your problem, start with the easier number, the simple number with only one unit, rather than the number with a complex unit. Start with the simple number. Number 6 on the back of the expert's homework sheet is appropriate for that lesson. A hot tub at a hotel where you are staying holds 550 gallons of water. Do you see how that's a simple number? And it needs to be filled after cleaning. The water pressure results in a flow rate of 2.31 times 10 to the negative third meter cubed per second. Now that's a complex number. It's a number of meters cubed per second. It's a flow rate of water going down a hose. How many hours, you want to get to hours, will it take to fill the hot tub? So start with the simple number. Start with the simple number. If you have 550 gallons of water, just put it over 1 so that you can remember that you're working with fractions. Well, I want to get to meters cubed. And so the first thing I would do is realize I have to get out of gallons. So I do know that there is 1 gallon equals 4 quarts. And then do you know the relationship between quart and liter? I don't. I'd have to look it up. But I've gotten from gallons to quarts. I would look up the fact that 1 liter is a little bigger than a quart. Well, a liter is smaller than a quart. That lets me get rid of my quart. Now, if I want to get to meters cubed, I do know that 1 liter is 1 decimeter cubed. This is an important equality for you to be able to use in dimensional analysis. That is that plastic box with all the little red cubes in it. 1 liter is 1 decimeter cubed. Now, can you go from decimeter cubed to meter cubed? This is a little trickier. What is the relationship between decimeters cubed and meter cubed? Deci means a tenth. So there would be 10 decimeters in this dimension, 10 in this dimension, and 10 in this dimension. So there would be 1,000 decimeters cubed in a meter cubed. Now I'm to meters cubed. Notice that this flow rate gives you an equality. It's telling you that That many meters cubed equals 1 second. So I'm going to take that and turn it into a conversion unit by putting 2.31 times 10 to the minus third meters cubed on the bottom. The reason I'm doing that is because I want to cross out meters cubed. And that was 1. And that's in 1 second. This is an important conversion factor that you got from the flow rate in the problem. This is an example of starting with the simpler number and using this more complex number, usually as a conversion factor in your setup. So now I've gotten to seconds, and they want to know how many hours. All I have to do is convert seconds to hours. There are 60 seconds in a minute, 60 minutes in an hour, so 60 times 60 is 3,600 seconds in 1 hour. If I do all that math, how many sig figs do I want in my answer? Going back to these two numbers, this has 3 sig figs, this has 2 sig figs. So I would write my answer to 2 sig figs. So I have shown you several of the more complex problems on dimensional analysis for experts. I won't always be going over homework here on these videos, but you need to do the class packet, practice there with me, then do your homework, checking your answers and seeing if you need help. If you realize you need help, get it. If you do need help, there are several places you can go. You can look at your additional resources. You can phone a friend and talk to someone about the homework. Find your study buddy. And lastly, 3 before me, you can ask me. So I'm going to share my screen back to my notes for this chapter. So in summary, video lesson 5 is asking, can you, 1 minute. One more time. Video lesson 5 is asking you, can you correctly solve a dimensional analysis problem by finding the correct equalities to use as conversion factors? Every time you have one equality, you make 2 different conversion factors. Can you recognize which conversion factor to use? And finally, are you more and more comfortable with 2 and 3 dimensions in our problem solving? So that's it for those 2 homework assignments. Remember, tonight by 11:59, you have 10-question quiz on these very topics. So I hope you are comfortable going into the quiz. You have 2 chances. Good luck. I'll see you tomorrow.